Platform Analytics provides for advanced analysis of HPC data, including jobs, resources, licenses, and more. In this module, I'll focus on the analysis of cluster capacity. Included are a collection of pre-built dashboards that give insight into capacity. By understanding capacity better, analysts, managers, and administrators can gain efficiency and plan more effectively. Over the next few minutes, I'll walk through some of these. I'm responsible for 4 clusters, 2 in North America, 1 in the UK, and 1 in Australia. Platform Analytics can collect and efficiently manage many years' worth of data. We're looking at data collected over a 1-week period from this environment. In this capacity summary view, I see a map of the location of my clusters. These maps can be customized to show locations within a data center, campus environment, or metropolitan area, using our own custom images. Pie charts overlaid on the map show me an analysis of slot status averaged over a period of interest. I see information about utilization for each cluster in each geography. The size of each pie chart corresponds to the relative size of the cluster. Data is provided in tabular form as well. The data shows slots, the basic unit of scheduling by the workload manager. Summaries of slots in various states are shown in both absolute and percentage terms. I can look at how my capacity is being used over different time periods. Time periods can be measured in hours, days, weeks, months, or even years. Because Platform Analytics is automatically gathering data from the clusters themselves, analysts always have accurate data representing the state of the cluster at any point in time. I can access information just by placing my mouse over any of the pie charts. On our US cluster, for example, we averaged over 2,000 job slots running, with most of the balance being idle. The pie chart view makes it obvious there's even more idle capacity in Australia. Over this period, most resources were either idle or down. An average of 71 slots was in use here, suggesting the environment could be over-provisioned. The real story is often more complicated, and I'll delve into the details in a minute. Let's focus on just the North American clusters. Down or idle over the period of interest. As with all analytics views, I can easily export the data if I choose. To get more insight into cluster capacity, we need to add the dimension of time. I'll select the Cluster Usage tab. The number of slots in each state and how it varies over the time period. We also see the pie chart representing averages over the period. Notice that we're still filtering on closed, down, and idle slots on the Canadian and US clusters. Platform Analytics remembers what I'm interested in as I move between data views. Let's look at things from a global perspective. All states. Note the unusual dip in activity on the US cluster on April 11th. This illustrates how just looking at averages can be misleading. The North American clusters were actually operating pretty close to capacity most of the time. Being able to perform this kind of analysis is key to making proper decisions about capacity. To reintroduce Australia and the UK into the mix, I see a different picture. If this trend was consistent through the year, this would tell me that we're significantly over-provisioned and that there's opportunities for cost reduction. Consistently over the week, there were 2,000 idle slots representing several hundred servers. At the very least, we should be powering these down just to save on power and cooling. Platform Analytics makes it easy to find opportunities for improvement that we can quantify in financial terms. Let's look at just the UK cluster. There may be a good reason for this, but it points to more possibilities to improve productivity or gain efficiency. Now I'll focus on just the US cluster. My clusters support multiple project teams and many users. Looking at capacity on aggregate is useful, but it's more useful to look at utilization by individual project. I'll filter resource use by project and show only project 21 because I know it's resource intensive. The resources used by just this one project. From a business standpoint, having global visibility to resource use by project is critical because any change in infrastructure ultimately impacts users and projects. This dashboard introduces the notion of measures and dimensions. So far I've been expressing my capacity based on job slots, but I might want to look at capacity based on another metric, like memory. Changes we're seeing memory use by this project. Spikes in usage like this one often point to opportunities for cost savings, as we'll see in the next modules. If I select users, the list of users is constrained to include just those working on Project 21. I can look at the resources used by just one user if I choose. This user was only active once during the week. I'll restore the view to include all projects and users. I'll break down resource use, in this case memory, by project. Now I see a pie chart reflecting how the cluster usage in the US over the week was broken down by project. It becomes evident that the reason for the idle period was due to one of our more demanding projects, Project 24, being inactive for a day. Perhaps this is because of staff absences. By understanding how and when project teams are using resources, I can make more effective planning decisions. By aligning users with resources better suited to their needs, I can improve the productivity of all project teams and potentially save or avoid cost. I'll look at a similar project breakdown based on job slots. Project 8's using only a tiny sliver of available slots, but you might recall from our previous view they were using roughly a third of the total memory. This points to how important it is to look at workloads from different perspectives to make informed decisions about capacity. Project 24 is consuming many more slots than our prior view would have suggested, leading us to conclude that memory requirements on average per job are more modest for this project. I might be interested in what users were responsible for the activity on Project 24. This helps us determine whether some users are taking more than their fair share of resources. I'll change the dimension from projects to users. We're still looking at total slots, but now we have a breakdown by user. On average, no single user is dominating resource use. I can place my mouse over the graph and quickly see what user is using what amount of resource, when, and for how long. I'll look at the Host Usage tab next. In this view, I get visibility right down to the host level. I can see exactly how long hosts spend in various states. I'll simplify the view by just looking at hosts with a slot status of running or idle. I might want to know what machines were used by individuals working on Project 24 and how long each was used. I'll filter to show only hosts running jobs associated with this project. Now I see each user, the hosts they used, and how long they tied up slots on the host. I can drill in further and look at host use by just one user. And I see the machines that their jobs ran on and for how long. Before I wrap up, I'll look at the Cluster Workload tab. I'm still filtering here to show only results for a single user in a single project on the US cluster. In this case, the measure is total slots used. I can look at resource use at different levels of time granularity. I'm looking at hourly granularity here. I'll expand the view again to include all clusters. The change in the chart shows that this user must be using resources on other clusters as well. I'll look at this single user's resource use across all projects. And now let's include all users. Now I see all the users that were actively using slots on any cluster superimposed on the same chart. By including hosts that are down, I get a sense of the relative proportion of resources unavailable relative to the actual usage by user. I can change the dimensions in this view as well. Instead of looking at slot usage by user, I can look at slots by cluster. I expect this to be static since the total slots remain constant over the week. Now I see the relative size of each cluster. I'll change the dimension once more to look at slot status. Now I see the number of slots in each state across all clusters and how the status changed with time. Recall our significant quiet period in the US. I'll select memory as the measure. Only jobs that are running actually use memory, so we just see a summary here of memory use across all resources. In this view, I can also focus on individual clusters. I'll select the UK cluster. I'd like to understand memory use by project in the UK. This view shows me what projects were active, when they were using memory, and relatively how much memory each was using. At this instant in time, jobs associated with Project 47 were using a total of 1.4 terabytes of memory across all UK cluster resources. I'll view this in terms of slots instead. And I'll remove the clutter by only focusing on slots that were in a running state. Now I have a clear view of what projects were busy when. Project 27, shown here in blue, dominated use of the cluster. Let's recap some of the features and benefits of platform analytics from the standpoint of analyzing capacity. While Platform Analytics provides for almost unlimited analysis, easy-to-use pre-configured dashboards make it fast and easy to get started. As we've seen, analysts can quickly pinpoint underutilized assets, determine whether they really represent spare capacity, and either reallocate these assets to a group that needs them, or possibly reduce spending. By providing visibility to how asset use is trending by geography, resource type, and project, Platform Analytics helps sites plan capacity more effectively. Platform Analytics provides better visibility to global operations, helping us identify bottlenecks, improve efficiency, and increase service levels to the business. I hope you've enjoyed this quick tour of capacity analysis in Platform Analytics. Thanks for your time.